All right, this is question 10. The variables A, B, and C in figure 8 are assigned string values. String values. Okay, A is assigned bitmap, B is assigned pixel, and C is assigned bit. Shade one lozenge which shows the concatenation of the variables. Concatenation of strings is where you combine them together one after the other to make a single string. So we're concatenating A and B. So we're concatenating this string bitmap with this string pixel, making the string bitmap pixel. So notice that there's no spaces here. So there's no reason to put a space inside here. So it's not this one, it is this one, bitmap pixel. Don't get confused with the fact it's A and B. These are the variables. We're not concatenating those, we're concatenating the values of the variables. Strings can also be represented as arrays of characters. And in fact, in Python, if you remember, if you've got an array or a list in Python with some values as their elements, etc., then you would reference A0 being this character, this one here in Python. And also you could have a string. So if you had something like my string equals bit, then you could also go my string 0 in Python. That would reference this B here. So arrays and strings are very, very similar in many languages. They're sort of all indexed in the same sort of way. Okay, strings can be represented as arrays of characters. For instance, the 3 statements below are an alternative to the statement shown above in here. So A, instead of being a string, now is an array of characters, and so is B, and so is C. For the following questions, array indexing starts at 1. So this is index number 1, 2, 3, 4, 5, 6. Remember, in Python, we start off at 0 here. But you'll notice in your exams, they often do start with indexing at 1. Shade 2 lozenges which correspond to the 2 true statements about these arrays. Okay, so hopefully your eyes are going to be drawn immediately to this thing here. This is OR. This is logical OR. And remember that OR has the following truth table. So if you've got two inputs, let's call those inputs. I don't want to use A and B. I don't want you to get confused with these A and B. So if I use capital A and capital B, remember A or B is also written, by the way, A or B, like that. That's another way of writing A or B. Remember, all our inputs, we have 0, 0, 0, 1, 1, 0, 1, 1. And OR is a bit like either or. So it means the answer to this one, the answer to this is a 1 if either or of these is a 1. So either of or of these are not a 1, so this is a 0. There is a 1 here, there is a 1 here, and there is a 1 here. So that's our OR table. So what we've got is our inputs are actually these things. So you could think of this as our capital A, if you like, and you could think of this as our capital B. So let's have a look to see whether A is true or false. Well, A1, so A1, well, that's a B, the character B, as you can see up here, A1 is a B, and B1, that's a P. So is the character B equal to a character P? No, it's not. It's false. So this is a 0. In other words, false. And let's have a look at B now. So A1, that's a B again. And C1, well, that's a B. So is B equal to B? Yes, it is. So that's a true. So that's a 1. So we've got A is 0, B is 1. So A is 0, B is 1. The answer is a 1, which is true. So this is indeed true. So that is definitely one of them. So we need one more to find. The length of B. Well, the length of B is clearly 1, 2, 3, 4, 5. The length of A is 6. Is 5 greater than or equal to 6? No, so this is definitely false, so that's not true. So we certainly don't want that one. Let's have a look at this one. So here we've got not. Outside of this big bracket here, we've got an and sticking in the middle. What does and look like? Just to remind you, if we've got A and B as our inputs, and A and B, another way of writing that, remember, is with a dot, A and B. 0, 0, 0, 1, 1, 0, 1, 1. There's our possible values of our combinations of inputs. And must have both ones in order to get a 1. So in other words, this must be a 1 and this must be a 1. And that's not the case here, nor here, nor here, but it is here. So that's what the and truth table looks like. So let's have a look at A6. A6, well, A6 is a P. Is that equal to B1? B1, that's a P. So this thing here, this statement here is true. So that's a 1. Now let's have a look at this one. Let's have a look at A3. Well, A3 is a T, and C3 is a T. So this is also a 1. So 1 and 1 is 1. So the answer to this whole thing inside these brackets here is a 1. But look, this not outside converts that 1 into a 0, because the not of something turns a 0 into 1 or a 1 into a 0. So this is a 0, which is false. So this is not true. Okay, D. Let's try this one. A, well, what is A? A is an array. And they're saying is an array equal to, well, what's A5? A5 is a character. And an array cannot equal a character, so that's not true. So it must be this last one, because which 2 lozenges? So we had the first one and the last one. Let's check to see whether it is true, just to make sure. The length of A, what's the length of A here? Well, the length of A is 6 minus, what's the length of C? The length of C is 3. So this value here, 6 minus 3 is 3. So this value there is 3. So we've now got the array at item 3. Well, that's A at item 3 is a T. So this is a T equal to C3. And C3 is a T. So T equals T. Yes, that is true. So therefore, we do get this truth here. .3. Develop a subroutine called prefix using either pseudocode or a flowchart, which takes 2 character arrays called word, so a subroutine here, 2 character arrays as parameters, one called word and one called pre, and determines whether the start of the character array word is the same as all of the character array pre. For example, let's say we've got these 3 arrays. A starts with the same sequence as C, because that starts BIT, and this starts BIT. So it would return true. B does not start with the same sequence as C, so prefix BC would return false. In other words, we're trying to see whether or not the first characters of one word are the same as the first characters of another, or the other one. Your subroutine should also work for character arrays of all lengths greater than 0, and not assume that the length of pre is less than the length of word. Okay, so we could have the words the other way around. So we could say that it works for that bit is part of bitmap, but also potentially, if these were the other way around, then that could possibly work as well. The start of the subroutine has been completed for you. Okay, so notice that they're getting subroutine, the word prefix, and this is our word, and this is our pre. Okay, so we need to determine whether this word or this array and all its characters are the same as the ones all in here.